Oh, hello everyone. So welcome to the second AGILE webinar. I'm Jing Yao, co-secretary of the AGILE Council, and I will be chairing today's session. I'm joined by my colleague, Dr. Yao Wang, who will be helping out with the Q&A later on. Just a quick practical note before we start. The session is being recorded and we will have time for questions at the end. Today's webinar is hosted by the Spatial Applications Division at KU Leuven. Our speaker is Dr. Naomi Thiru. Naomi is a research associate in the division and specialized in geospatial data science. She will be sharing insights from one of the division's projects, Urban Data Spaces for the Green Deal. With that, I'll hand over to Naomi.
Thank you. Thanks for the introduction. I'll share my slides now. It's not in presentation mode yet, I can see. Think. No. What is it that you see on your screen? Sorry. I'm only using one screen today, and it's a bit confusing how to move to the. Are you seeing a presentation, or you're seeing the PowerPoint?
Just a PowerPoint, not a presentation mode yet.
Presentation mode is normally down here, but it's for some reason blocked by.
On the bottom, yeah.
Yeah. Okay. Should be in presentation now, yes? All right. So my name is Naomi Thiru, and I'm going to present today the concept of using urban data spaces for decision making. So I will go through the process of how we built up a data space and how this was targeted for municipalities. So when we talk about urban data spaces, we're really talking about the municipality or cities being the largest stakeholder in an urban data space. And it's supposed to be responding to climate challenges that cities are normally dealing with. So I will maybe skip this slide. It's an introduction of the division that we work with, but I can quickly say that the mission of our division is to develop, provide, and expand academic and operational expertise in geoinformation and technology. So these kinds of projects, which is for instance, the project that I'll present today is a Horizon project. So we work as in a capacity of scientific consultancy with applied research backgrounds, let's say.
Sorry for interrupting.
Yes,
Naomi. So it's still in editor mode.
It's still in edit mode.
Yeah, at least from my side. Oh, can you just make the slides like bigger?
Okay. Is presenting Teams an option? No. What if I do this? What do you see now?
Yeah, still like editing mode.
Oh, that's very strange because I can see it in presentation mode. That's a shame. Slideshow.
Yeah.
I don't know how And even slideshow doesn't give that. Still no? Because I see it in presentation mode now.
Okay, move to next slide.
Do you see?
Yeah, we are seeing the first one.
In presentation mode, yeah? Or no?
No, like editor mode. Can you try to move to the next slide? Yeah.
Okay, so that's not working. Then maybe what we can do is I just zoom in here.
Yeah, zoom in, yeah.
Maybe it's my sharing mode. Let me stop sharing for a minute.
Yeah.
And
Stop sharing and share again.
Way. Yeah. Sorry about
No,
this.
it's okay. It's okay.
Yeah.
Yes.
Is that in presentation mode now?
Yeah.
Okay. All right. Take two. So I'll start about the urban space data space for the Green Deal. The urban data space for the Green Deal, also known as USAGE or abbreviated as USAGE, was a project was a Horizon Europe project that lasted for 36 months from 2022 to 2025. So it came to a conclusion a few months ago. It had 4 pilot cities, Zaragoza, Ferrara, Graz, and Leuven. I am in Leuven, so I was involved in the developing tools and resources for the Leuven pilot, but also collaboratively for the other pilots as well. So the objectives of this project was to facilitate the process of stakeholder engagement in the use of Earth observation and IoT environment data. We worked a lot with satellite imagery and also with sensor data, which is quite valuable when you start talking about climate and climate challenges in cities. We had to evaluate the available architectures in the different pilot cities so that we can identify what is missing, the missing elements, so the tools that already exist and what tools are needed to be able to develop the necessary resources for these pilot cities. We also had to identify standard-based data models and formats to ensure interoperability within this data space. And I will present to you how we achieved that. We had to, at the end, formulate recommendations to implement urban data spaces. So this had to be replicable in other pilots. By the end of the project, we had some interested sister cities, that is what we call them, in the different countries. So we had people who were already interested in replicating the work that was done in their respective pilots in these different countries. And we had to collect the necessary and missing data to run all of the tools that exist and what to be developed in the project. Yeah, okay. So the formulation of the urban data space for the Green Deal starts with the EU Green Deal, let's say, and the EU data strategy. So this is the starting point for the formulation of an urban data space. And these from the EU Green Deal, which informs the local Green Deal, that the pilot cities at the very least had their own local Green Deal policies, and also based on the EU Common Data Spaces project, which hopefully you've heard of this. So there's this EU Common Data Spaces project that has been implemented and is also, was initiated several years ago, and it's currently being implemented in different sectors. I think there's 14 sectors of data spaces, and we fall under the Green Deal data spaces. So the urban data spaces, and in particular this project, we focused on building the components of a data space, integration of governance, what it means to govern a data space, and also looking at sustainability of the entire project and the resources that have been developed. This is an overall methodology of this project where we start from understanding the potential needs, understanding the needs and the potential scenarios of these pilot cities. So we did a status quo study to see what is it that these cities have, what is it that they need, who are the people who participate, and we move to looking at data, so understand all of the available data, and that is local data. And when we start talking about data, there is what is open in the municipalities, let's say, and then we also have private data providers. So is this data available in terms of, does it exist? But then is it also available in terms of, can we access it? Is it something that can be shared from whoever who holds it? And that brings up the concept of a data space. So a data space consolidates the data access in whatever way. It doesn't have to be open, but accessibility is something that can be formulated in the way that it needs to be formulated for whatever use case we're discussing. And it's not just about the data, it's about also tools, because it's not about data layers. It's about data layers that have information that is useful to target specific challenges of the city. And a big part of the project, of course, was looking at policy, involving policymakers, data preparation for policymakers, generate expertise in Green Deal scenarios, etc. So this is the initialization process of the project. Like I explained before, we did interviews and desk research just to understand the status quo of the cities and understand the challenges and the needs, and identification of data and the different data sources of this data. So in understanding the needs, we start at what are the policy priorities of the cities. So the policy priorities are what determine where the focus would be in terms of a use case. So we have the use cases here, we have the policy priorities, and we also have the local climate challenge. And this is supposed to be an iterative process where we look at the policy priorities, we look at the climate challenge, formulate a use case to be able to address this challenge, and in that way also go back to the policy and see if it's achieved, all the ways that it needs to be updated, all of the ways that it needs to be extended or changed, or all of that. So this is the general process of how our data space would work. So this is what we identified in this. So in the policy priorities, some of the policy documents, let's call them, that addressed how we identify the particular use cases for the pilots are the EU Adaptation Strategy for Climate Change, EU Biodiversity Strategy, Covenant of Mayors, which 2 of the pilot cities are participants in the Covenant of Mayors, as well as the EU missions, Committee of Regions, etc. The local climate challenges in this particular, because you will find that urban challenges tend to be similar. You have areas that are very built up, they will have urban heat island issues, they'll have flooding issues, they will have loss of biodiversity issues. So we were able to have this general climate challenge areas. So we had a climate action, adaptation and mitigation. All of these ontology as well is directly what is listed in the EU adaptation strategy and climate change. So we try to do one-on-one mapping so we can have everything as aligned as possible. And the different use cases that we came up with are here. These were implemented all in, some of them were implemented in the different pilot cities, all the pilot cities, and then others only in a few pilot cities. So we had the part where we did the collection and integration of existing data and solutions. So that means looking at what is existing, like I mentioned before, and what the needs would be of working with these existing data and solutions. So that's, for example, these are the existing tools that were available across all the partners, because the partner we had, if I can explain the structure of the project, is that you have a pilot city, and then you also have policy experts, and you also have technical experts. And amongst all these members of the consortium, you find that you have tools available, already developed in different projects, already available in the different municipalities, and all of these were made available to each other's projects and to each other's pilot cities. So we started with a series of tools that already existed and that were applied, and I will demonstrate later how that was done. And we did also a collection of existing data. So that this was for tools, and this is data. So the pilots and all the data that is available to them. A lot of this data existed with the municipalities. Some of it had to be collected in the course of the project. Some of it had to be purchased for very specific purposes. So for example, if I can say in Leuven, we had data collection flights where we collected hyperspectral images and aerial thermal images. We had existing LiDAR data, we had existing DSM, DTM, etc. And also some of this data collection was done as well with the sensors in the other pilots. So this shows the integration of the data. And the implementation of the missing resources is what is it that we foresee? What would we foresee to have or to create in the course of the project to address some of these challenges? So this is just a preparatory list of this, and this is a demonstration of how these tools and assets appear in the metadata. They will talk about the metadata catalog later in this presentation. So the use case conceptual model. So I will start by saying that in our project, the urban data spaces are very use case based. So it's not just about sharing of data, it's about producing of decision ready information. Decision ready information is produced at the end of a use case. So the different pilot cities have these challenges, and these challenges are structured into use cases around a certain value chain. So the value chain is about processing data. You have input, throughput, and output. Each use case originates from specific local challenges, and the outputs are developed with a focus on semantic clarity, and interoperability to ensure that they are understandable in the different contexts. So this is the development of the usage use case conceptual model. So we start with the European Green Deal policy area, which addresses the local Green Deal or the city contracts. And these are linked to the strategies, plans, and regulations of a city. And from here, we identify what are the challenges and priorities of a city. When we identify the challenges, we develop a use case. So what is a use case? A use case encompasses several processing steps. These processing steps are formalized by a processing requirement, which is fulfilled by tools and algorithms. So all of this is done beforehand, where what are the different processing steps that we need to achieve something, and what is the requirement for this? And that's going to be a tool or an algorithm. That tool or algorithms works with input data. So we have an input data set, and we have an input data requirement. So an input data set is what exists. A data requirement is what is required and possibly doesn't exist yet. And after you have that, then you have your output data sets. So once you have your tools and algorithms and you have your input data sets, all of these are documented in metadata. So we use standardized metadata profiles to document all of the tools and all of the algorithms and all of the resources that are developed. And we also use the same to document the data. And all of this forms the infrastructure of a data space. So as you can see, its use case, it's centered around a use case, but then it has all of the components that are required of an urban data space. And when you have all of these components, what we're looking to develop is decision-ready information. So just a quick word about the use case definition. This is how it was done with the business process model and notation, that's BPMN. So the BPMN helps us to break down all of these different processing steps, and it identifies all of the data and tools for each step and highlights the gaps. Of course, this cannot be seen here, but if you zoom into an area, you can see how this process is really not trivial. If this is done at the level, at this level of granularity, you will be able to see exactly what it is that you need, exactly what is missing, all of the things that have to be developed. This is just a zoom into a particular area. This is a zoom into the final, after you've achieved your decision-ready information, for example, for this use case that's been selected here. In your BPMN, you also have to have links to all of these tools that are needed, to all of the input data. So when you create it in this way, if you break down your use case in this way, you can be able to really bring together all of the different parts that are necessary to develop your use case. And all of these different parts are what form the urban data space. So decision-ready information, as mentioned before, is something that goes beyond data layers. It's defined collaboratively together with the stakeholders. The tools and algorithms transform this raw data into decision-ready information. And in the public sector, this plays a critical role in empowering the policy and decision makers and administrators. So decision-ready information is created either with individual or chained tools and algorithms. And the decision-ready information addresses either one very particular issue or a series of issues that are quite well defined. So we'll talk about the selected use cases in a bit. Give me a second. So these are some of the use cases that we worked on in this project. One of the use cases is a urban heat island identification. So the goal of this use case was to, in the city of Leuven in particular, the goal of this use case was to provide information to help the city identify and analyze urban heat islands and to locate areas with high heat exposure and vulnerability. So for this use case, we had two decision-ready information. One was an LST map, so that's a land surface temperature map, that was created using Sentinel-2, Landsat LST band, and a tool was developed for this. So there's an urban heat island calculator tool that aggregated the median temperature over a 10-year period. So with this data, the city of Leuven was able to see very clearly, because of course in different months, this map looks very different. But if you do an aggregation over 1 year and then over you do a temporal analysis, then you can be able to have a map that more definitively shows actually where the urban heat islands are. And even from this map, we're able to identify that these parts that are have the highest temperature overall are the industrial areas, and the ones that are quite cool are the forested areas. And from this map, we were also able to calculate vulnerability index map. So this is something that's calculated with the LST map. So this is a decision-ready information on its own, but then it also forms the input for this other use case, which is creating the vulnerability index map. So we use that and socioeconomic variables. So the location of schools, health services at different ages, and this is expressed as, the vulnerability is expressed as a percentage. So you can be able to also do a comparison with the two. That's what the city did. And you're able to identify that even the areas that have the highest temperature are not the areas that have the highest vulnerability, because what is considered vulnerability for the city is where the vulnerable populations live. So people don't live in the industrial area, but then you'll find a place that is maybe not as hot, but if you put together all of the different factors, then you can identify the exact spots that have that fall into the category of vulnerable. So this was the urban heat island use case in Leuven. In the grass pilot, on the other hand, the city was interested to know what the added value is of aerial thermal data as compared to satellite thermal data. So, of course, the resolutions are very different. The aerial thermal data has very, very high resolution. It can show very more exact data because the resolution is very high. I think this resolution was 0.7 centimeters or to 7 centimeters. Yeah, and this the satellite thermal image is I think 30. We're working with 30 meters on the ground, so the difference is very high. So this use case in particular just looked at calculating urban heat islands with the different thermal data and a comparison of the two based on the surface material on the ground. So you can see with the satellite thermal image, it's not really very possible to differentiate the different materials on the ground high enough or precise enough to tell the difference or to tell the effect of surface materials on the ground. So with the thermal image, it was possible to do this. And with this classifying, or rather this graph here, which was really possible to see with the satellite image, everything sort of levels off at one place. But with the aerial thermal image, you can really see the exact effects of surface materials on urban heat island based on the high resolution thermal images. So this is what the municipality wanted. They wanted to know, because we know where the hotspots are, is it possible to know, to see anything further about this? And we're able to demonstrate that the surface materials have a high impact on your urban heat island, and this is demonstrated with the aerial thermal maps. In Leuven, we also executed a potential green roofs use case. So the use case aimed to identify the most suitable location to install extensive green roofs. So this is based on geographic location. It doesn't address possible other limitations of buildings, just looking at where they are located, how suitable is it to put a green roof, and also some properties of the roof. So we looked at the surface material of the roof slopes, the roof areas, and a combination also of the vulnerability maps that were calculated before. And this decision-ready information, which is the potential green roofs suitability map, is something that the city needed because the city offers premiums to facilitate the installation of extensive green roofs as part of its greening initiatives. So because there is premiums and there is communication between the city and the city dwellers when it comes to accessing these premiums, the city was able to have a data set that they can already identify either who can apply for these premiums and who maybe they need to motivate to sort of apply for these premiums. So they can check when an application comes in, but at the same time, they can also send out letters or something to motivate building owners to consider putting green roofs in their buildings. And it's not just green roofs, it's just this is the use case for green roofs. But the city of Leuven has this initiative for many things, for unhardening your front yard, unhardening your backyard, putting a water pit in your backyard, planting a tree. There is all these initiatives, but there is no data that can help them to really know what the impact would be. And that's what this use case was able to achieve for them. We also have an implementation of the 33300, which tries to classify residential buildings according to their access to green public infrastructures. This was implemented in Graz as well. So the city also wanted to know this, to know how their population, or what percentage of their populations are exposed or can be able to access green spaces. And so this use case was executed, and we came up with this categorization. So you have 0, 1, 2, 3. So 0 means it's a building that does not fulfill any of these 3 conditions. So it's not, there's no 3 trees visible from this building. It's not in a neighborhood that has 30% of trees, and the distance to the nearest green space is longer than 30 meters. So this classification was done, and we created a data set that the city would be able to use to take decisions on this. Almost the last use case. So this one is a calculation of photovoltaic potential in Ferrara. We also implemented this in Leuven. So the goal was to assess the solar potential for photovoltaic installations in the city and identify the most suitable areas through solar irradiation analysis and exclusion of non-applicable zones. So this was tied also to green energy. And in Ferrara, it was also very important because there's a lot of air quality issues and air pollutions because of the location of the city that's right at the valley next to old industrial areas. So they still have these remnants of really bad air quality, and they would like to eventually move from that kind of industry. And that means that we have to stimulate more taking up of green energy. So this use case was able to achieve a decision-ready layer, which is a layer of roof building footprints, or more importantly, of roofs and exact roof planes, and how much potential they have for solar irradiation. How much is it that we can extract, if that's the correct word, we can extract from these roofs if we install solar panels. Part of the use case also involved identifying the existing solar panels and excluding them. So that's what is meant here for exclusion of non-applicable zones. So this means that these are really the areas that don't have solar panels yet and cooled. And if they're cooled, this is how much we will get from them. So we look at the highest ones, and we can be able to see which are the areas that can achieve this for the city. This is a surface material classification. So this was a machine learning project to identify the surface materials. This was done, I think, in all of the pilots where we were able to identify the surface materials. This created layers that were used for other use cases, but then it also created a layer of data for these particular cities. Final use case that I'll speak about is an emissions monitoring dashboard that was developed for Zaragoza. And this was an development of an emissions inventory in which the emissions are shown to decision makers and citizens, and they're aggregated by different sectors. So this data is usually very classified, that's the word. It's not available for the people, but then in this aggregated way, it was made available for the public. So the process was to identify the existing data, and that this data is important and it needs to be shared to the public, to different stakeholders. And the best way to share it would be to aggregate it. So it was aggregated by different cells. Cells these are different cells. So the cells were defined. So what constitutes a cell and how much emissions is within that cell. And it was also done by district. So we have a bigger representation of this, and then you have a more precise representation of this. And now this data, these layers are made more available to the people for them to be able to, if you have a day that is being represented as a high emissions day, which happens sometimes, then you can take your own personal decision on what to do about it. Is it the day that people are not outside that much? What is it that we would do with this kind of information? So these dashboards are already live and they are being used by the people of Zaragoza. So the final part, which is actually not final, I would say it's really a central part of a data space, is metadata and cataloging. So all the different tools that are needed to produce all the different layers that we have discussed, and all the input data that is required for this is all cataloged. And a catalog is an infrastructure that is set up. So we have, for instance, we use GeoNetwork. So GeoNetwork provides this web catalog where you can be able to share data with each other. You can be able to harvest data from each other. You can be able to document data in a standardized way. So we were able to set up, this is a project catalog, but I should mention that all of the pilots have their own separate catalogs. So the project catalog just brought together the data from the different catalogs, but then also the different pilot catalogs also had data harvested from their federal level or from their other different locations. But the idea of the metadata and catalog is to create a federated catalog, which is just a combination of catalogs brought together to share information. And it's really sharing information about the data, not necessarily the data. The data can be, it can be made available through the catalog, or it can be, you can give conditions of access for this. So the catalog retains records of both data as well as the tools and algorithms. This is based on ISO 19115 or DCAT as well. It supports FAIR principles. Data governance is provided through lineage documentation. So we have sections of the metadata record. If you can see this section here, that gives the lineage of this data. So it gives information about what is this data layer, how was it processed, using which tools. It has also parts which give the licensing condition, the licensing that is assigned to these resources, and it gives conditions of access and use. The metadata also provides links to the resources that have been published. So in this particular project, we were able to publish all of the tools that we created. There was a decision that all of these tools that are created within the project are open. They're open and we share them amongst each other, and they're also open to anyone who would like to use them, to extend them, to combine them with other tools. So we published the tools on GitHub, and we have information about these tools also in the metadata records. So for example, here you can see there are a roof segmentation tool, which is a tool just to segment roof pitches. And this was part of the tools that was used for the solar potential as well as the green roofs use cases. So the links to all of this would be, you can find them in the metadata. The urban data space governance was also one aspect. So we also explored the different ways in which data spaces can be governed so that they're useful for these urban areas, for these cities. So it means that we have a data space which contains the data, processes, services, and tools. It can be regulated by a data governance ordinance. This is very exact for Zaragoza because they have a data governance ordinance, but it's something that we looked to adopt for the other pilots. And the data space has one-way or two-way communications with different parties. So the City Hall is a big stakeholder of this, sharing data providing data to the data space and also receiving data from the data space. You have third-party companies. They can be data providers and they can also be data consumers. And then you have citizens who are mostly data consumers, but they have access to an urban data space. So our data governance ordinance manages these interactions between all of these different parties. Like, for example, having data sharing agreements or contracts with third parties and companies, or having different entities of a municipality, like different departments, sharing the data into the data space, but they maybe can still retain their own data. They don't have to put it all in one big pot, let's say, but they have to make it available to within the data space to all of the users of the data space. So in conclusion, how do data spaces support decision making? So first, they break the data silos, which means that the data silos are really about a lack of communication about which and where the data exists, which data exists and where it exists. And in a data space, it means that you bring all of this data forth. Bringing it forth means that it is it's well cataloged, and the catalogs are shared amongst each other. And if possible, links to this data is also shared within these catalogs. It improves trust, especially when it comes to decision-ready information, where you have provenance of this data, how this data was created, and hopefully this leads to quality information, increasing the confidence of the use of this data, because you can clearly see how it was made, and you can also inspect the tools that created this, decide whether it fits your particular purpose. The data spaces enable insight, not just access. So it's about data analytics and not just raw data layers. It means that decisions can be made much faster. It supports scenario testing, because now you have tools that are shared within the data space, and you can be able to see how these tools were applied with all of the different links being shared within these catalogs. You can see the different applications of these tools and the different outputs of these tools as well. And you can see whether that can also work for you. You have easy access to this. It aligns stakeholders, the departments, agencies, and cities. They work from the same evidence base, increases transparency. So decisions are traceable to underlying data, assumptions, and analytical methods. And it also has where you can reuse the data products in tools and workflows to enable replications across the domains and cities. I included this last slide in the event that this presentation is shared, where you can find the link to the usage website, the Urban Data Space for the Green Deal website. So here we have all of the documentation of this project. So you can be able to also see the progress of it. You can focus in on one pilot if you would like. You can see all the people who are involved, and even the sister projects that were done, because the Urban Data Space for the Green Deal had other data space projects being developed at the same time. And all of these are documented in this website. It is still available, and I think it still will be available for coming years. Thank you.
Okay, thank you, Naomi. Thank you very much. The presentation contains lots of information and many insights. So we have time for a couple of questions. So any questions from our audience? Yes. Let me allow. Yes. Yeah, from you.
Okay. Yes.
Yeah.
Yes, thank you. You hear me, do you?
Yes.
Yeah. Naomi, thank you for the presentation. I'm very interested by this concept of data space, but at the same time, I'm wondering what the new elements are compared to what we used to call spatial data infrastructure. For instance, in the city of Leuven, they have a powerful GIS, which makes use of web services, etc., to connect to other repositories. So now we seem to call this a data space, but I'm not sure whether I understood actually what the differences are between what we used to have already and what the data space concept brings in addition.
Well, I would say that a data space, even as it's been documented in the development of data spaces, is called a modernized spatial data infrastructure. And it's called this because it has the layer of decision-ready information first. So it's not just people sharing data, it's data being produced by the different players. So you have more stakeholders. It's not just public administrations. So you have invitations also to private data providers. You have invitations to private technology, how do you say, tech, let's call it that, people who will develop these tools. So you have a wider range of stakeholders. And urban data spaces, in this particular case of the urban data space, is that it's also very focused on very specific challenges. It's not just a place for sharing data. It's about sharing data that is very particular for a very particular challenge. And in that way, you can invite specific people who maybe are a bit shy of sharing their data, or they're unsure about how their data is going to be used, that we can create this space where we can share data that maybe is a bit sensitive, but we can share it with us because we want to achieve something. We want to create certain decision-ready information that is useful or it is needed by the city. Understand? So I feel like a data space kind of goes one step beyond spatial data infrastructure because it can be very specific. It can also be as small as is needed. So this one in particular is small because it's based on particular city challenges. So we did it, of course, as a consortium of 4 particular things. But in this case, we can just say we created a data space for Leuven for climate challenges. So if we need, like we needed these hyperspectral images for processing certain things. So data is collected for this one specific thing. And this data is owned by a private person who only shares it for this exact use case. So I feel like those kinds of components, they enhance trust, they enhance working with each other closely for very specific outcomes. I think that for me, that would be how I would say a data space would differ or would be a better thing from a spatial data infrastructure. But of course, the discussions are still quite vast. It's still not very, I mean, it's still a challenge, or it's still also quite challenging to really pinpoint the thing that would add value. But I think the thing that adds value in this is the very specific data sharing methods. Yeah.
Okay. Thank you.
Okay.
Thank you. Any other questions? Yes. Okay. Yeah, go ahead. Yes.
Another term we like to use nowadays is the term digital twin. In this case, an urban digital twin, or a digital twin of an urban territory. Is that applicable here?
In this case, a digital twin would be a separate infrastructure from a data space. So a data space holds the data, and a digital twin, the way that we would connect it, which is something that we also explored a little, maybe not to its full completion, is how this decision-ready information can be represented in a digital twin. So the data space can be where the data is held and it feeds into a digital twin as needed. But a digital twin, in as much as they have very similar architecture parts in terms of input data, asset cataloging, connecting different parts of this infrastructure, the digital twin still has this real world data, and what we create are actually scenarios. So our decision-ready information is a scenario, and a scenario can be actually well represented in a digital twin. So I think there can be that connection, but the data space really focuses on data, and in particular decision-ready data, where the municipalities can actually take decisions from what has already been processed.
Yes, but you agree that there's lots of semantics involved, and we still probably need to standardize the terms we use for the different things. But thank you very much.
I agree. Yeah, thanks. I agree.
Thank you. Any more questions? Yeah. Okay. I have a question. So, you mentioned at the beginning that this project already finished the last year. So I'm wondering, any other following up work? Do you have any other following up work or projects?
You mean out of this particular one, or just any other?
Follow up this one, yeah.
A follow up of this one. Unfortunately, well, there is a proposal that we started to put together, although the time ran out, which would have been ideal. It actually consisted of the consortium members that we worked with already, and it was about actual implementation of these resources. So there was Horizon funding to be able to assist cities in implementation of solutions that come out of such Horizon projects. So that is something that can be followed up on. But then what I can say directly is that there are some cities, for example, there was 3 cities, if I'm not wrong, in Italy, in Ferrara, who were interested in the solutions of from this project. We actually also had some from Leuven, which we're still following up on, that hasn't materialized. But in Ferrara, we had some cities that actually followed up and have signed documents to be able to collaborate with municipality of Ferrara in implementing some of the solutions that exist in our data space, the data space that was created in this project. So in that way, it's very direct. That I would say that some of the tools that were created in this project, we have implemented them in other existing projects, like the Urban Heat Island tools that we created here. We were able to implement them in other current projects that we have in our department. So I would say that we created resources that we are still able to extend and apply in other places. But that's only for Leuven, but we have also many members of the consortium who I'm sure are able to utilize these resources further than the project usage.
Okay, thank you. Thank you very much. So as I mean, for the data you collected and the data space you built, is it like free access to all like researchers?
Yes. So currently, in the project catalog, we can find all of what is openly available there. We have other data that is not openly available, but it's still accessible with requests, like the high resolution imagery. Some of that is not directly downloadable, but it's accessible. So we can find that there, yes.
Good to know. Thank you. Thank you very much. Any other final questions?
We had a PhD.
No. Okay. So if no further, Yeah, I mean, if you have any other further questions, please feel free to contact Naomi. I believe she would be very happy, to answer any inquiries. This brings us to the end of today's webinar. And thank you so much again, Naomi, for a really engaging talk. And thanks to everyone who joined us today. The recording of this session will be made available on the AGILE YouTube channel. Our next webinar will take place in March, led by Technical University of Munich. So please keep an eye on the mailing list for details. We hope to see you again at the next AGILE webinar, and have a great rest of your day. Bye, everyone.